Okay, let's start. I hope they will join soon. Okay, so firstly, I would like to ask all of you, did you do any work or design? I want from you to show me your screen, your design, your results. Okay, so that we can discuss it in detail. Okay. So first, Ambrish, did you design any antenna? Okay, so why did you not done it? Is it difficult task? Okay, dear John, did you design any antenna?
Yeah, I know. I've not been able to do it yet. There are certain things I need to catch up. That's why I've not done it yet.
Okay, okay, okay. So because you yesterday you paid the fee, I will share the recorded lectures with you. Okay, today.
Come again.
I will share the recorded lectures with you. Okay, today, in short.
Okay, okay,
Okay,
okay. Once I get it, I'll try and do it.
okay, okay. So the next is Majid. Did you do anything? Because today task is for you. You know very well. This is assignment one, and you have to show me the design so that I may know about your situation.
Yeah, I'm working on it, but where I'm having challenges is the how to do the ports.
Did you do anything?
I'm working on it, but I'm having challenges with how to the port this thing, how to do the port, how to attach a port to it.
Okay.
Yes.
Do you want to show anything to us?
Oh, I don't actually have anything to show because that thing is giving me a challenge. So I'll do and then delete it. I'll do and delete it.
Okay, all right. So I don't think anybody did any work. Next, Masood, did you do anything or do you want to show any design? Because the design I assigned yesterday, the task I assigned you yesterday.
Actually, I'm sorry, sir. Today I have exam, so I cannot uh, design properly. But I'm practicing one design, but I'm not simulating.
Okay, who is presenting? Tariq, you are presenting. You want to show us? Can you speak, please? Hello, Tariq. We are not able to hear you.
Hello,
Yes,
can you hear me?
yes. Now we can hear you.
You can see my screen.
Yes, I can see.
So this might design is take me more than 12 hours. I didn't sleep for
Yes.
optimize about it.
Because this is your first design. Okay, design looks good.
Yeah.
And okay, now can you show me the S1 one?
Okay.
First, show me the dimensions of the antenna.
Okay.
How much dimensions? Go to the view option in the toolbar. Yes.
Dimensions. You can see my dimensions here in the
Yes.
parameter list.
Yes, you can. You should also use that tool. Yes.
It's 24
Okay.
for the width, and for the length
Mm-hmm.
is 30.
Okay. And which substrate you have used?
Of course,
FR4. with thickness
For
1.6 millimeter. Okay.
yes, it's 1.6.
Okay, all right. Now show me the S11.
For S11 is the current
Okay, for which type of simulation did you done? You have a lot of simulation.
is approximately 2.45.
Okay. Now can you show me the bandwidth?
The bandwidth, okay,
Yes. By marking the curves, or you can do.
1 second. Is 0.17
Okay, 0.17 gigahertz. Okay.
gigahertz, yes.
Okay. And
And for Z reference is 15 ohms.
okay, good.
And for the radiation, you can see my radiation.
Okay, go to the 1D plot.
What?
Go to the 1D plot on the toolbar.
Where?
In the toolbar.
I can't hear you good.
I mean, can you see the 1D plot in the toolbar? Because this efficiency is in dB. Okay, we don't need in dB efficiency.
Ah, okay, okay.
Yes. Okay, okay. So your efficiency is more than 85%, I think. Okay, can you
It's
mark
good or
there?
not? It's good or not?
Yes, it is good. Yes, it
Okay.
is good because you can see here your efficiency. I mean the total efficiency and the radiation efficiency is very close to each other at 2.45 gigahertz. Okay, it means its gain will be good. Okay, it will be positive gain.
Okay. And for the gain is bad gain.
Okay, show me the gain.
This is the gain, and we can see more good gain. Okay, 2D.
Mm-hmm. Okay, it's
Okay,
1.22.
1.2.
Okay, show me the 2D
It's not
pattern.
what?
2D pattern
Okay.
or polar plot. Okay. One. Can you show me the polar plot to see the pattern? 1D plot, and also check the axial ratio
Uh,
in the far field. In the far field, can you click on the axial ratio in the far field at 2.45 gigahertz? Do you understand me?
Mr. Ahmed, you can hear me?
Yes, I can hear you.
Okay. Just problem with
Okay. Can can
what
you
said me?
can you show me the axial ratio in the far field?
Okay.
Go to the 1D plot. Yes, okay, it is 140 dB. Okay, means it is.
It's linear.
Yes. Okay, and that what is again is 1.22 dB. Okay,
And
sure.
VZWR.
Yes, it is less than 2. Okay. Okay, show me the
And for surface current,
yes, show me the surface current.
1 second. Surface current.
Okay, nice. Okay, first tell me either you design this a new shape or follow any paper.
We start from old design and we modify from circle design and then modify.
Okay, this is not a published design, right? This is
Yes,
you
yes,
designed it
yes,
just now. Okay, this
yes.
is new
It's
one.
not design.
Okay, okay, okay. So okay, design is good
And
and
for the formula, you send it to
waveguide port.
that side, the force coplanar.
Mm-hmm.
I do the same what you tell me.
Yes.
Okay.
Okay, now show me the design. Go to the components and show me the design to give you some suggestions. Okay. Okay, this design is good, and you can do design steps of this design. Okay, and other thing, if you modify some ground plane, like you make some slots to check at the S11 at the if it is able to increase the bandwidth or not. Okay, with the CPW, I mean.
You mean here slots?
Yes, in the ground plane, in the ground plane.
Oh,
Okay, if
okay.
you, yes, if you try to make any slot in the ground plane. Okay, or which version you have, which CST version you have?
2020.
Okay, okay, no problem. Okay, so you need to I can you write some suggestions on your paper, or I can you write here, or I will want to give you some suggestions. Okay, so that you can try it, and maybe this design will have more better results, and we it can go with the publication. Okay.
Okay. Okay. Thank you.
Okay, first you need to try with the CPW ground plane. You need to make some slots and check the behavior. Okay, one is the at the corner of the CPW, for the left CPW, the left top corner. Okay, yes, left
Oh,
top corner, left top corner.
we mean here.
Yes, you need to make a slot at an angle of 45 degree. Okay, to check at
Semicircle, like semicircle, or
no semicircle, just a horizontal slot at an angle of 45 degree.
okay.
Okay, on the both side. Okay, like it will become a V shaped slot. Okay, but patch should be coincide with each
We
other.
mean, Mr. Ahmed, we
Yes.
mean any shape or specific shape.
Okay, just zoom out. Let me take a snap, and then I will share you my screen, and then I will,
Okay.
okay, tell you which one is better. Okay,
Okay.
show me your complete design. Okay.
Like this.
Yes.
Good.
Yes. Okay, can you wait a minute, because in the screen there is another option in front of me to okay, can you shift your design on the right side, like near to the toolbar, because in the mid of this my screen I have some options, because I am cannot take snip tool. Okay,
Where?
near to the toolbar.
Yes, where exactly?
E-
I
uh,
didn't understand you.
okay, don't worry. Let me, okay,
I
now
didn't answer.
just leave it. I'm sharing my screen.
Okay. I will stop my sharing or not?
uh, Wait for a minute. Okay, let me
Okay.
explain here. I was talking about this option because I am not able to take snap because of this option. You need to show me your design here. Okay, so that I can take snap.
Ah, okay. Okay, okay, I understand, yeah.
In the, you can see here, this you can choose this option. Okay.
Okay, okay, okay. Just I missed his understanding.
Mhm.
It's good like that.
Yes, it's okay. Okay, so you have this design at 2.45 gigahertz. The bandwidth is somewhat good, but it can be improved. Okay, or you can do some optimization. Okay, of this design in many ways. Okay, uh, like you have this front view. Okay, and you have a back view. You have nothing on your back plane. Okay, so suppose you have this back plane. Okay. Okay, So let's discuss it. Okay, first you need a try with the slots here. Okay, slots like this. Okay, and slots like this. Okay, and this patch, this short patch will be connected in this portion. Okay, in this portion. So you need to only make some horizontal slots at this point and at this point. Okay, in the first attempt. Okay, just a try. Okay, and simulate either the results change or not. Okay, on both sides. Okay, this is the first attempt. Okay, in the second attempt you need to
Mr. Ahmed, please repeat.
okay, you make need to make a horizontal slot. Okay, at an angle of 45-degree on the ground plane. Okay, at like this.
Okay.
This is a slot. Okay, and also on this here. Okay, so you need to make some horizontal slot on the both side and need to check the results. Okay, either what is the change in the results. Okay, you need to keep your all save your all results in the word file. Okay, just take snap and
Okay.
paste in the word file. Okay, this is your first attempt. Okay, in the second attempt,
And this slot can improve my bandwidth or the gain?
yes, it can improve your bandwidth. Okay, so just a try. Okay, and the other thing, you need to cut here this portion. Okay, and also of the ground plane. Okay, and also of this one. Okay, it can you also try this one to improve the bandwidth. Okay, this is the second step. Okay,
For the entire ground plane or just portion?
just small portion. Okay,
Okay.
because at this point if you do the whole, then here you will have a connector and it will change your results. Okay, a lot, but you only need some portion. Okay,
Okay.
okay, the other thing, if you make this one like this, because in one of my design I made like this. Okay, so, to improve the bandwidth, it may become wideband. Okay, you need to create a triangular patch here. Okay, to connect this circle. Okay, okay, suppose this is a patch. Okay, let me
And it's connected with the patch.
yes, like this. Suppose this is your patch. Okay, like this. Okay, it may improve your bandwidth. Okay, like this. Okay,
It's like 45-degree or
yes, 45-degree. Okay, you can use the other tool in the picture. Maybe you will have go to the modeling.
okay. 1 minute.
Okay, you can use this option. Okay, curves. You can click here, double click here, double click here, double click here, and connect this one. Okay, and then you can create a short patch here.
Okay.
So this is other suggestion. Okay, uh, okay, there are so many other suggestions, but for the moment you may know about shorting pin. I don't know whether you know about it or not.
Okay.
So and other attempt, you can make another slot. Okay, it will become a multi-band. Okay, like this. You can create another slot here and also another slot here. Okay, do you know how to slot this, make a slot like this?
No?
Okay, so you don't know. Okay, you can make a circle. Like you can first you need to create a patch, circular patch. Okay, in this
Okay.
point. Okay, in this point. Okay, then you need to cut the patch, I mean cut the circle. Okay,
Okay.
then like this, let me show you here. Let me delete this one. Like this, like you have this CST and you want to draw a circle here. Okay, and okay, suppose this is your circle. Okay, and you want to cut this circle. You need to cut this circle from the top side. Okay, like this. Okay, so you have cut the circle. Okay, so you need to create another slot in the circle like this. Okay,
Oh, okay. I
so
get you.
yes,
Yes.
then you need to cut this slot from this patch. Okay, this patch.
Yes, it's very easy. Yes.
Yes, so it is very easy, you can design any shape. Okay, so this, it will be good for you if you try this one. Maybe it will become a multi-band, or it can be a circular polarized antenna. Okay, and also try with this one. Okay, try both.
Mr. Ahmed,
Yes,
can we know the position of the slots just from the surface current?
yes. No, not with the position, but wait a minute. Okay, you need to also need to give a try this one. Okay, and this one. Okay, the connected patch. Okay.
Okay.
Okay, now go to the surface current. Okay, you can see here, yes, increase the density.
Okay.
Okay, and one more thing, this is your surface current at 2.45 gigahertz. Okay, it means if you create a slot in this red portion, then your 2.45 gigahertz frequency will change. Okay, but if you create another slot like this one, okay, like this one, then it will not disturb your 2.45 gigahertz. It means your 2.45 gigahertz will remain the same, while the other you may able to generate another band. Okay,
Okay.
okay, so
Get you.
do you understand what I mean?
Yes, totally. Yes.
Okay, because as I told you, in our each design we need to show the design steps, and there must be, if you have many design steps, then it is good to explain. Okay, you can explain the design very well, and it can be able to publish in a good journal. Okay, so that's why I am telling you to modify some ground plane so that you can do its
And for
optimization.
sorry, Mr. Ahmed, I
Yeah.
share my screen here.
Yes.
It's correct for the
uh,
port.
okay, this is 2 cross, yes, wg cross plus 2g. Yes, you define g as a gap.
Yes, as a gap.
Okay, okay, it's okay. Okay, good work, Mr. Tariq, well done.
Thank you.
Okay, so you can stop sharing. Okay. Okay, did anybody, Mr. Zubair, did you do anything, please?
Yeah, I have a design. I design one, but I have a simple page for the terahertz. I do it.
Okay, you can show us if you want.
Okay, I will show.
You can share your screen.
I have it in another laptop, so I will after class I will put it in a USB. I will show you.
Okay, because today lecture is to show the designs. Okay, okay, so Mr. Tejraj, can you show us your design? Can you share your screen?
Hello.
Hello, can you share your screen, please?
Yeah, one moment, sir. Actually, I haven't yet finished my this one, but let me share.
Mm-hmm.
Uh, the screen is visible.
Yes.
Once. Actually, I have tried a lot, but I am not able to get some
proper result actually.
Mm-hmm.
Just I made a simple patch actually, and then try to create some slots on the patch. Right now I
Mm-hmm.
haven't cut this. I just this is the S11 parameters actually, but these are not the optimized result actually.
Okay, so did you create any slot in the design, or can you show design?
Yeah, actually, sir, I have tried, but I have just reversed all the operations right now. These are the one second. Actually, I have worked on HFSS, and in this
Mm-hmm.
CST I have worked first time.
No worry, it is
So
more
for the
easier.
designing part, it is really very hard for me. Uh,
Not very hard, it is
because
simple, but you if you
uh,
have able to design any one design, you can design any shape.
like these slots I have cut actually, but right now I haven't do. I have just reversed the operation. But after the using these slots, still I haven't get the proper result actually.
Okay,
This
so
S11
did
parameter,
you
this
see
frequency
any
has been shifted to the
hmm
yes, yes,
did
please.
you see any change when you created the slots?
Yes, sir. Actually, in S1 in these S11 parameter, this frequency will be shifted towards the right side,
Mm-hmm.
not on the 2.4 gigahertz, and it will be shifted around 6 point something and near about 3.5 to 4.5 around.
Mm-hmm.
But whenever I just try to reduce or increase the length of the patch, that again there is no proper result on the S11 parameters actually.
Okay, for the moment it is working at 4.8 and maybe 7.3 gigahertz frequency.
Yeah, yes sir, yes sir, right here.
Okay.
So what can I do? Actually, I have also tried another. I have made some horizontal slots actually, near about 5 to 6 slots horizontally
Hmm.
of 1 mm width.
Okay,
But still,
can you show the
yes sir.
ground plane? Where is the ground plane?
Mm, yeah, this one the ground plane actually. Full ground plane I have used in my design.
Okay, so if you reduce the size of the ground plane, I mean the length of the ground plane, if you
Yes sir.
reduce it from the top side, then your frequency will shift towards the lower frequency band. Okay.
Means quarter wavelength. Suppose this is complete L and L by 4. I have to just remain.
Yes, if you have L by 4, then you if you reduce the size like L by 2, okay, then it will shift your frequency towards the lower frequency band. Okay.
Okay, and one more thing, sir.
Yes.
What about the this is the front side actually.
Okay, select the component one. Okay, so that you are able to see your complete design. You are just selecting ground plane. Click on the
Yeah.
yes.
Okay. Yes, yes, sir.
So what is your question?
Okay. Apart from these slots, can I try another one, something else, which is better for this part actually?
Did
Or
you
I am
try or
happy
you
with these
want to
slots and
try?
the partial ground plane.
Yes, you can do it. Okay, you can use partial ground plane. Okay, if you are facing in the resonant frequencies, you can shift your frequency if you reduce the length of the ground plane. Okay.
Okay, sir.
Okay, you can try more. Okay, maybe you will get more better results.
Yeah, sure.
Okay. Okay, so
Yes, sir.
good
We'll
luck.
try.
Okay.
Thank you.
Okay, next, CEO Park, did you do anything, please?
Yes, sir.
Not from you. You can turn off your
Oh, okay.
microphone.
Okay. Oh,
I am asking to CEO Park, Mr. CEO Park. Okay, Muhammad Rizwan, did you do anything? Because this is the first one, first lecture.
no, sir. It's in process, sir. Soon I will submit, sir.
Uh, did you do anything? Do you want to share your screen?
Sir, on
searching, sir. I need more time, sir, please.
Okay, you can take time, and those who did not design your design yet, you can, if you once you complete, you need to show me the results and design. Okay, because in the next task you will have some complex shapes. Okay, it is easy if you start with your simple design. Okay, otherwise in the next okay, in the next lecture it will be hard for you.
Sir, I have a question, sir.
Yes.
So why don't we consider Smith chart, sir? It also gives information about the inductance, capacitance,
Yes.
impedance, particularly.
Some people like to add Smith chart in the paper. Some people do not like. Okay, because in if you want, you can add in the paper. Okay, or if you don't want, then it's up to you. Okay, because in most of the papers, research paper, people do not like to add Smith chart. Okay, because the main concern is the designing of the antenna and to target the application. Okay, there is even no people or very less people talk about the impedance matching and other things. Okay, they just focus on your design and the application and the operating band and how much is efficiently working for the desired application, like you design the antenna for underwater communication, then how much is effective in water. Okay, so these things matter a lot in the good journals. Okay, because these things like impedance matching and these things are very common now. Okay, that's why this is not suggestible. Okay, but if you can, it is you can do it. Okay, if you can want, you can add it. Okay.
Alright, sir. So in antenna designing, radiation pattern is very important, sir.
Yes.
Sir, how about, sir, last time you discussed about the cross polarization and co-polarization, where you obtain the gain in phi, phi 0
Yes.
and phi 90 degree.
Mhm.
But sir, I think I missed, or perhaps, sir, I don't find the cross polarization and co-polarization graph result, how we obtain co-polarization and cross-polarization results, please, sir.
Okay, for the moment I do not have any design. I mean simulator file. I need to design from the beginning. Okay, Mr. Tariq, can you show me your design if we can implement it on your design?
Okay. Yeah, I have problem just. You can see my screen.
Yes, we can see. Okay, now go to the far field. Okay, now can you first show go to the click on the 1D results in the folder above. Do you know how to create a new folder in the 1D results?
Okay.
In the 1D results, go to the 1D. Yes, now right click on it. Okay, now okay, just okay. So now go to the far field. Okay, at 2.45 gigahertz. Okay, so you need to copy the data. Okay, now first click on the 1D results. Okay.
But 3D is not, I can copy.
Yes, but you cannot see all the graphs. It is better if you can see 1D results. Okay.
I copied this graph.
Not this one. Go to the far field plot in the toolbar. Yes.
Yes.
Why it is not showing 2D pattern? Can you change the 2D pattern? Tijral, can you turn off your microphone, please?
Mr. Ahmed, please, I can't hear you.
Yes. Now you can hear me.
Yes, now it's good.
Okay, I am saying that can you show the 2D pattern? Okay, in the 2D pattern you must have click on the small arrow inside the 2D pattern, below the 2D pattern.
Can you show me my screen?
Okay, let me share my screen so that you can see where I am, what I am talking about. Okay, now show me your design.
I did.
Your design. You are
Okay.
sharing your screen.
I share my.
Yes, yes. Are you sharing or where you are sharing? I'm not able to see yours. Okay, let's leave it. I will show you. Okay, just turn off your let me start with the beginning.
I'm sharing my screen, Mr. Hamza.
Yes, but I am not able to see here.
Okay, I will stop and share it again.
Okay, okay, yes.
Yeah. Can you let me share my screen?
Yes, I think multi persons can share the screen.
Because I can't. He said me this will let you take over from Saraj Ahmed as the main presenter.
Okay, now you can.
Okay, now I can.
Okay, I now go to the far field option. Far field option. Okay,
Far field.
good. I am
And
just
then?
directly telling. Okay, actually in the 2D pattern I am not able to see uh, the polar plot. Okay, you know polar plot.
Yes.
Okay, click on it to yes, this one. Okay, now you can see okay, scroll down this one, the folder option. Okay, now here you can see, everybody can see there are axial ratio option, there is a theta and phi. Okay, theta and phi. Okay, for the copolarization, as I described earlier, for the cross polarization you need to put the phi is equal to 90. Okay, now click on the phi in the folder option. Yes, click on the phi. Now are you able to change the go to the far field plot?
What do you mean?
Okay, in the toolbar where you can see realize gain.
Okay.
Okay, here is the acute angle. Can you modify the acute angle at 0 degree?
At 0 degree.
Yes. Okay, phi equal to 0, so cross polarization. Okay, so this is your cross polarization at phi is equal to 0. Okay, now copy this folder, this file, and paste in the new folder you have generated. Okay.
Okay. I have problem. I think I can't.
You can press Ctrl C and paste there. Yes. Okay, now go again. Okay, now click on the phi and change the phi is equal to 90. Okay.
Okay.
Okay, so this is your copolarization, phi is equal to 90. Copy this and paste in the folder. Okay, now rewrite the name. Click on the name. Yes, phi is equal to 0. It means it is cross polarization. Okay, you rename the file. Okay, first name not this one, I mean far field 2.45. Yes, this one. This is phi. Yes, now write its name. Phi equal to 0 cross polarization. Okay. Yes, and for the second one is copolarization at phi equal to 90. Okay, you also need to write. Okay, so this is for phi. Okay, you need to create another folder. You create a new folder. Okay, now go to the theta. Now click on the theta. Okay, and how much angle? This is 90-degree, right? For theta is equal to 90-degree, this is called cross polarization. Okay, copy it and paste in that folder.
For this angle.
Yes, copy it.
Okay.
Okay, copy it and paste in the same folder, in the new folder. Okay, where you have pasted the others.
And then, Mr. Ahmed?
Paste in the new folder.
Yes, I did.
I'm not able
I
to.
pasted in the new folder here.
Okay. Now click on the theta is equal to 0. Now change the angle. Theta is equal to 0.
Okay.
Yes. Copy this and paste in the folder. Okay, this is for the theta, and the above folder is for the phi. Okay, can you copy the other two in the same folder? I mean, all the four phi's in one folder.
For the last folder.
Yes, copy these two files. Yes, copy this and paste in the previous folder. Yes. Okay, now you can see. Okay, now click. Can you click on the green copolarization, green one?
Okay.
Double click on the, yes. Now you can.
Sorry. The green is copolarization.
Yes. Okay. Can you extend the name? Copolarization phi is equal to 90. Okay. I mean name. Extend the name.
Okay.
Copolarization is underscore phi is equal to 90. Okay. Okay, leave it. Just click on the new folder to show all the design. Okay, actually in the you can see here there is a cross polarization and copolarization. The red one and the blue, sorry, the red and the green one is the cross and copolarization of the phi is equal to 90 and 0 degree, and the this is orange. Yes, this is orange, and blue one is for the cross and copolarization of the theta. Okay, in the case of the copolarization, yes, copolarization should be less than minus 20, okay, dB. Okay, click on the new folder.
Okay.
Okay, copolarization should be less than minus 20 dB. Okay, and the other one you can see is the cross polarization. Okay, in most of the paper you will see cross polarization and copolarization together. Okay, so just an angle difference in the angle, no any other change. Okay, in the case of the cross polarization you put the phi is equal to 0 degree, and while the theta remain constant. Okay, but in the case of the copolarization you put the phi is equal to 90 and the theta remain constant. Okay, but if you want to calculate for the theta, mean yz plane, then you put the theta is equal to 0 and keep the phi constant. Okay, and for the theta is equal to 90, you calculate the cross polarization of the theta, and in that case you keep the phi is equal to phi constant, I mean. Okay, I will send you the graph that I have show you in the previous lecture to understand more clear about in that case. Okay, but if you want to calculate the cross polarization and copolarization, you can do this procedure. Okay, as I told you, just go to the theta and write the values, and you can write 0 and 90. Okay, in this way you can calculate the cross polarization and copolarization. Okay, you can turn off. Yes.
Mr. Ahmed.
Yes.
And I see some video for E plane and H plane. They changed it here. Is that true? 0 and 19.
Yes. This is E plane your, okay, and the other 5 is equal to 0 is your H plane. Okay.
H plane is 0 or 19?
H plane is 0.
Is 0.
Yes. This is your H plane.
I thought is 0 is E plane.
No, 0 is H plane, okay, and 5 is 90 is equal to E plane. Okay.
Okay. Okay.
Okay, you can stop your sharing. Okay, so I'm trying to share my screen to pass these some more time. Okay, I will try to teach more things, maybe better for you.
Excuse me, Ahmed, can I share my screen with you?
Yes, please.
Is it okay?
Yes, now you can show the design.
So this one I follow one of the paper. So I just draw a sample to do some. I didn't do some modification, but I have to. You should to give me some of suggestion for to change the patch antenna or something like that. I have a result.
So you use the full ground plane.
Yes, this is a full ground plane.
Okay.
And this is for like for this something like for the terahertz is from 0.6 to 0.75 terahertz.
Okay, so which substrate you have used?
This is FR4.
Okay, as I told in the previous lecture, at the terahertz frequency, the FR4 substrate is not much acceptable. Okay, because at terahertz frequency, the size of the antenna is very compact, and you need to use some other Roger or any other substrate that is has very less thickness.
Can I use like a polyimide substrate?
Yes, polyimide substrate is available of thickness 0.05 millimeter. Okay, 0.05 millimeter. Okay,
0.05 millimeter. Okay, sir.
and you can use that materials. Okay.
So now I want to change some modification in this one.
You can but you should try to start with the with 2.45 gigahertz frequency, because this frequency is very high, and you see your design will have more bandwidth. Okay, because your frequency is in terahertz. Okay, like if we design the antenna at 2.45 gigahertz, then our bandwidth will be in megahertz. Okay, but in the case of the terahertz, our bandwidth will be in gigahertz. Okay, but I prefer you to first start with the gigahertz, that I suggest you 2.45 gigahertz, so that you can easily see the change in your design, and you will have a big design, and you can modify your shape, because in terahertz you need to know so many things, like the thickness of the substrate, the name of the material you use for the substrate, and the thickness of the patch, and many other things. Okay, that's why. And also there are lot of questions arises for the terahertz, like for the waveguide port you cannot use this you want to publish paper on terahertz, then many reviewers will ask you why which type of connector you have used for the terahertz, because the normal connectors we use can work up to 50 or 40 gigahertz, not more than 600 as you are using here. Okay, so there is a special type of port for terahertz frequency. Okay.
Okay. I actually am working here on a terahertz, so that's why.
Yes, I know, but for the start, you need to work on the so that you may learn different things. Okay, then you can convert you just need to change your frequency band. Okay, otherwise you just need to start with the lower band, so that you know the how to design and different things. Okay, because here it may be difficult for you to keep the thickness and many other things, because when we study about the terahertz we need to keep in mind so many things like thickness of the copper and waveguide port and the substrate material and boundary condition, many things. Okay.
Okay, I understand. Thank you.
Okay, good luck. You can do it. Okay, you can follow any paper and you can work on it.
Okay, okay, thank you.
Okay, for the moment we have time, so we can discuss a few more things. Okay. Okay, are you able to see my screen?
Yes.
Sir,
Yes.
sir.
Yes. Yes.
Sir, please, just once again, please tell me how to create a new folder to store the results actually right now. Yeah, in
Yes, when the 1D results, you can go to the create a new folder like this.
okay.
It is very simple.
Okay, means in 1D, 2D results we can create a new folder, you know?
Yes, you not in 2D, but only you can create a folder in 1D results. Okay.
Okay, in 1D results.
In the 2D
And
results, you
one
will
more
not.
thing, sir.
Maybe you will not have option. Let me check. You can see you are not able to. In the 1D result you have option like this, but in the 2D results you don't have any option. Okay, I use some techniques here, so that I will explain. First let me create any shape here, a simple patch. Mr. Zubair, you can turn off your microphone.
Sorry.
Okay, I will give you some more tasks in some of the paper, or some people like to use connectors in the CST software. Okay, they don't like to use waveguide port, discrete port and other ports. Okay, they use connectors like for CPW, or they use coaxial probe in the designs. Okay, so in this video I try to show you how to do work on it. Okay, so first let me create a very small patch so that we can feed it. Okay, let me check if I have because I already saved the uh, connectors. Okay, I made some port videos in connectors here, but for the connectors okay, so I run this video. You can watch this one. Okay, maybe I can upload this one with this video. Okay, and you can see here. Okay, let me start. But this is the problem, this is a dual layer substrate. Okay, but maybe okay, let's check. First tell me either you are maybe I did not record the voice here. Okay, so I record the voice in parallel with this video. Okay, so are you able to see this design? Okay, this is a full ground plane. Okay, I made, and there is a patch. Okay, and I want to feed this patch with a coaxial probe. Okay, so for that I need to shift my WCS, or just first I need to check the line impedance. Okay, by clicking the you can see 4.6 is the epsilon value of the substrate, FR for substrate. Okay, and in this way you are calculating your line impedance. Okay, so I am just checking at which values the impedance is at 50 ohm. Okay, so I am giving try many times to calculate the 50 ohm. Okay, so you need to check either which frequency which parameters the impedance is 50 ohm. Okay, okay, so in these values you have line impedance 50 ohm. Okay, so D is the you can see the diameter of the line. Okay, feed line. Okay, now I'm going to create here, okay, a port. So first I need to create a cylinder, or first the probe. Okay, the feeding probe. Let me show this one. Okay, I am going to make this one first. Okay, the central feed line, and then I am putting the same radius I have calculated with the calculations. Okay, and the 10 is the in the VW max direction. Okay, like this, and minus 0.05 is the thickness of the copper. That's why I have used minus 0.05 and minus 1.6, because the thickness of the patch and the substrate. Okay, and this feed line is made of copper. Okay, so you can see just a simple feed line that touches the patch. Okay, now I am going to make a PTFE like this one. Okay, the blue one. Okay, you can see this one, this is sky blue color. Okay, this is made of PTFE substrate. Okay, PTFE. Okay, after creating a field line, I am going to make a outer of with the PTFE. Okay, okay, here you notice I am the outer radius starts from the point 33 plus 0.35. Okay, from this point. Okay, you can see, and the inner radius should be with the diameter of this, okay, probe. Okay, like this. Okay, so I will extend it more, the outer radius. Okay, this is 2 that I have calculated in the calculations. Okay, and the same length of the PTFE. Okay, you can see, and other thing you can notice here, let me, okay, you can notice here one more thing here, that I did not use here minus 1.6, but in the probe I use the minus 0.05 minus 1.6. okay, in the probe that is made of copper to feed the or extrude the patch. That's why I have connected the probe with the patch, okay, by putting the values of the, by inserting the values of the substrate and the patch, okay, because the height of the substrate is 1.6, that's why I have used in 1.6 millimeter, okay, and then I have used minus 0.05 millimeter. This is the thickness of the copper, okay. Then for the PTFE I am only using minus 0.05, okay, because as I told you, PTFE is the name of the substrate, so therefore I use minus 0.05 millimeter. It means this PTFE is now connected with the substrate, this FR4 substrate, okay. So both substrates are now connected with each other, okay. So you can see here I forgot to change its material, so I am going to the load material and write here PTFE, and you need to choose lossy PTFE and click OK and click OK, okay. So you can see this is your PTFE substrate, okay, sorry, PTFE cover, okay. Now I want to make a core, create a core. Let me explain here this one, okay. I have made this pin, okay, feed pin. I now also I made this PTFE, the outer, okay. Now I am going to create a core, okay, core, the outermost outer layer, okay, the red one, okay. And from where it will start, it will start from 2 millimeter, okay, because the diameter of this PTFE is 2 millimeter, okay. So I will start the cover from 2 millimeter, okay. So you can see here, okay, I write here 2 millimeter to start from the diameter of the cover, okay, and 0.35, okay, is the thickness of the cover, okay. Okay, one more thing here to notice, that the inner pin, this one should be connected with the patch, okay, and the PTFE must be connected with the substrate, because the PTFE and FR4 both are substrate, okay, and the outer cover that is made of copper is connected with the ground, okay. So there are three things, okay. In the design we also have three things, the three layers, I mean, the first layer is the patch layer, okay, the second layer is the ground layer, the second layer is the substrate layer, the third layer is the ground layer, okay. So in the same way, in the connector, in the coaxial probe, you have three layers, okay. The first one is the feeding pin that is connected with the patch, okay. The second layer is the PTFE that is connected with the FR4 substrate, okay, and the third layer is the outer that is made of copper and it is connected with the ground, okay. So you have completed this one, okay. Now in the CST you need to insert these feeding pin, okay, in the from the substrate, okay. Okay, you will find our option here, I'm going to show you, okay. Now you need to select the feed, okay, you need to select first the yes, okay. One thing here, as I told you before, the feeding pin must be connected with the patch, not with the ground, not with the substrate, okay. So it means the feed pin should not be connected with the substrate and the ground plane, so it must be directly connected with the patch only. That's why I'm here going to insert the feeding pin from the ground and substrate, okay. If I use this option, the last option, did you notice I click on the insert option, okay. uh, no, yes, insert, okay. Now I click the insert option to insert the feeding pin from the ground and the substrate, okay, and I click the feed pin and press enter, okay. Now you will see a hole in the substrate, okay. And again I am going to what I'm going to do next, I am going to do again the I'm selecting the ground substrate, okay, and yes, even if you do not do this step, it is acceptable, okay. Just you need to, because they are not inserted in the because the PTFE is not inserted in the substrate, okay. If even you do not select this substrate, it is acceptable, okay. Here I choose the two options, the ground plane and the substrate, and click insert in the boolean and press PTFE and press enter, okay. Okay, now I'm going to oxide this one, okay. Just select the outer layer and go to the waveguide port, okay, and press ok. So in this way you can see your port is generated, coaxial probe, okay. Now I'm just directly running the simulation, okay. After completing the simulation, it will show you results. There is a long simulation, okay. Simulation takes time, so it will give you results, okay. Did you understand the procedure of the coaxial probe? I will upload this video, okay. How to calculate the line impedance, and how to create this feeding pin, and then the PTFE, and then the outer layer. Did you understand the procedure?
Yes, sir.
It is not difficult, just to remind these, just to keep these values in your mind, that how much should be the value of this lower diameter of the pin, and then how much should be the diameter of the PTFE, okay. Then you need to go according to that. So here I am doing calculations, okay. So do you have any question?
Excuse me, Ahmed. Can we do that like if we first cut the ground and after that we add the probe and the feeding, like something like, can we first do like the cut?
Which type of cut you mean? You mean to cut the probe from the substrate and then create another probe? You mean like
Yes,
this?
yes.
Uh,
Like first on the ground, first we do the cut as we like in geometry data we use like 0.32. The same cut will be on a ground plane. After that we put the probe add with the page.
yes, you can, but I'm not sure whether the results are will be okay, because you see in the video I did not click the subtract option, okay. Let's go to the in the video. If you notice, I did not click on this subtract here, because I have an option here of subtract, but I did not do this one. I only do the insert option, okay. You see I have option of subtract, but I did not click on it. I click the insert option, okay, to insert the coaxial probe, the pin from the substrate, not subtract, okay. But I think it will work, because you mean to subtract the size of the probe from the substrate and then create a probe. I hope it will work. It will work.
No, at the first, once we, from the beginning of the feeding point, first we cut the ground, and then we will subtract the ground like this, like the mentioned diameter. We will cut the ground. After that, we will put the probe inside that mentioned cut position.
I hope it will work, because in some of my designs I did in this way, and I hope it will work with you too. You should try this one, okay, and tell me whether it is working or not, okay.
Okay.
But I suggest you this simple way, okay, because you no need to cut anything, okay. This is a simple way. I think I will have some examples, like I already have a connector in CST. I have designed, okay, already
Sorry,
connectors.
Mr. Ahmed.
Yes, please.
Can we create the coaxial like this, but in the front of the patch, not below the patch?
You mean with the feed line, like we have a patch antenna and
Like we create waveguide one.
Yes, you can. Actually, there are three types of connector you can make in CST. The first one is this one with the coaxial probe that is inserted below the, I mean, from downside to upside. Okay, in through the substrate. Okay, this is the first method to oxide your antenna with coaxial probe. Okay, the second one is the, as you have designed the CPW antenna, and you can design a CPW waveguide port. Okay, you can see in the connectors, let me, like you have this connector, you have four legs, and the inner one is the feed pin. Okay, so in the CST, you can do this. Okay, you can, if for the actually use this connector in all of the cases. Okay, suppose if you want to, you can use this one. Okay, in all of the cases. Also we have other connectors, but you can use this one also for other, for coaxial probe. For in order to use as a coaxial probe, you can cut this all the four legs. Okay, this leg and this leg and this leg. Okay, you can use the inner as a coaxial probe. Okay, but if you want to use it for a CPW, then you need to cut, uh, I think this one. Okay, you need to cut these two legs. Okay, the down two legs, and you can you can design. Okay, or you can also design in CST. Okay, you have CPW antenna. Okay, let me draw in the PowerPoint.
Mr. Ahmed, what is the maximum range frequency of this connector?
I think it works up to 40 gigahertz, because I have tested some design and it works for up to 40 gigahertz. Okay,
Okay.
but not for the terahertz frequency. There are special mini connectors for the terahertz. I don't know the name of these connectors, the number of the connectors, but they are small size mini connectors for the terahertz frequency. Okay, and also we use that connectors for the implantable antenna like this. Okay, okay, so suppose you have this design. Okay, and you want to draw a connector. Okay, I mean, for the connector you will have three pins. Okay, one pin here to oxide this feed line, and the other legs of the connector. Okay, and you have a connector like this. Okay, okay, like you have a connector like this. Okay,
And
okay,
this connector is can affect on my result.
no, it will not affect your results, because this is a CPW, and for sure you need a ground. Okay, you need to connect the you will connect the other two legs as a ground. Okay, you can see you have a ground on the left side and the right side. Okay, so you connect the two legs of the connector with these ground. I mean, solder the connect legs with these ground plane. Okay, and feed pin with the feed line of the your antenna. Okay, to oxide this antenna, and it will not affect
I,
your
I,
results.
I mean, Ahmed, if I didn't soldering very good, is effect?
No, if you did not solder, there is no change. I mean, you will have some difference in the results, but not much. Okay, but must keep in mind these two must not be soldered each other. Okay, with I mean, they should not be when you are soldering, then they should not be connect with each other. Okay, just keep in mind these things.
Okay. Okay.
So I have some examples in CST. I will look for it, okay, and I mean the CST files in which you can directly, like you have this design, okay, you can copy the whole design from one CST file to another CST file, okay. So in the same way, like I have a connector in CST, okay, when you open that connector in CST or ready-made design of connector, you need to copy that this component and paste directly over where you want to connect the connector, okay, in the another CST file. So I will download, I have saved the files in the Google Drive. I will look for it and I will send you on WhatsApp, okay. You can directly use that connectors in your CST, because in order to design the new connector it takes much time, so it is better you can use ready-made connectors in CST, okay. You just need to paste there and just assign the waveguide port and you can run the simulation.
You said there are three types
Yes.
of fitting.
Yes.
What are the others?
Okay, I told the two one, okay. I told two like for the coaxial probe, to excite the antenna from you need to cut these four legs, okay, to excite from bottom down to upward, okay, like as I have done this one, okay. This is the first type. The second type is this one, okay, CPW, and the third type is you are not using this ground plane, okay, like you are not using CPW ground plane, you are using a full ground plane behind the antenna, okay. So in that case you need to cut the upper two legs, okay, and this shorting pin will connect the patch, I mean the feed line of the patch, and these two will be connected with the ground on the other side of the substrate, okay.
And the one, where is the connector?
I did not understand what you mean.
And for the one case, where is the connector, like you designed in CS?
For the which one? For
the one port, like this port, where can you show me the real pictures?
yes.
Okay. Like this, yes.
For one port, yes, you use this connector, and for the other port, if you have two ports, like you have a two port antenna, then you can use two connectors simply.
Mr. Ahmed, you can't understand me. Like in CST, when you design this connector here, coaxial port.
Yes.
Where is the correct or the preferable connector?
Okay, now relate the actual connector with the CST, okay. Now suppose you want to use the connector for the antenna that have the full ground plane behind the substrate, okay. Suppose this example, then in that case, in the real connector, you have to break these legs, okay, the upper two legs, okay. So in the CST you will not design these two legs, okay. You will design only this probe, okay. Because in CST files I have three CST files, one for the coaxial, one for the CPW, and one for the other one, okay. So in that case you need to delete you will not design these two legs in the CST, you will only design these two legs, okay, in CST. Or you can create a very small patch to connect the ground and the connector, okay, in CST.
Okay, I understand you. Okay.
Okay, so do you have any other question? I will try to upload this video, okay, or maybe I will cut this video from this point. Yes.
We can also draw like from from which we calculate the diameter of both the inner and outer conductor. From that we also directly build the coaxial feeding.
Yes.
Can you show us? So is it?
Yes, actually I use this you mean this one, home. Go to the home, go to the macros, then click on the calculate, and then go to the analytical, this one, okay, like this.
Yes, and build 3D.
Yes, it can build, but let us try this one, okay? Because I did work, but it will not. Okay, let us try. But let me.
0.3. Yeah, it's too easy.
Yes, but it
And
will
one
not
thing is,
directly. Okay,
No,
physical and.
I think not. You can't.
Okay, let us try. It can maybe. Okay, let us delete this one. Okay, and you have a coaxial probe here. You have very small size probe here. Okay, in build.
so from the line we can exceed, I think,
Yes,
from the line length.
yes, you can.
Yes.
Actually I directly use the, I mean directly design the probe, but if you want you can use this if you know well how to use that option. Okay,
Okay.
because
Uh,
it
Is
does.
the
Yes.
Is there any effect of frequency that you given for the 5 gigahertz? If we do like for the 2.5 gigahertz, so it will be affect the result on
No,
impedance.
as I told you that connector will work up to 40 gigahertz, so this is acceptable for all frequencies.
Okay, okay.
and for the value of the coaxial, I think you can't change it. It depends on fixed value.
You can change here, you will find option
But
here.
it depends on the connector that you have.
Yes, actually, no, actually, you see the this one like in setup solver, time domain solver, we have clicked the option of 50 ohm impedance. Okay, it directly assign 50 ohm port. So if you have suppose if you have big connector or very small connector, then if you, but it must be of 50 ohm. Okay, it is not a problem that you have a big size of the connector and like this, but it must be of 50 ohm. Okay, because in
Yes,
reality we also have small connectors and big connectors. Okay,
yes, because I thought that we must put the fixed value of the coaxial.
yes, but you see when you calculate this this one wait a minute, sorry, like this one, suppose if you have a different substrate and calculate this one, and suppose then it value will not be same. It means if these values are not same, then surely your connector will not be the same of same size. Okay, you will have of different size connector.
Okay.
And also you can do for others also for coplanar waveguide. Okay, you can give a try here. Let's suppose like this. Okay, so this is uh, your CPW for CPW. But if you know well how to use this, that's then I allow you to use. But I just tried in my life uh, sometimes, but I did not prefer to use this tool. Okay, 3D tool.
Excuse me, Ahmed, can we use for the coaxial feeding, the substrate will be always be Teflon or something like that? Can we
Yes,
change it?
yes, it is of Teflon. Okay, PTFE is a
Okay.
Teflon,
Oh,
because inside the in every connector it is made of Teflon material. Okay, Teflon or PTFE are the same. In CST you cannot find the option of Teflon, so you can find PTFE. Okay, PTFE is actually a Teflon. Okay, that has the same properties. Okay, you cannot not, if you write Teflon you will not find option here. Okay, so in CST it is PTFE. Okay. Okay, so what is the question? Have used 0.05 value in design of profit, and what is 0.05 mean? Actually, yes, in this video I use the for the probe, like for this probe. Actually this is not actually I use this minus 0.05 Actually this is minus 0.05 is the thickness of the copper, okay, of copper of the ground plane, because I am inserting the probe of by keeping the value same values of the copper and the substrate. Okay, so the substrate height is 1.6 millimeter and the thickness of the copper is 0.05. Okay, that's why I have used these values, okay, to insert the probe from these ground and the substrate. Okay, so if you don't have any question we can end the meeting, but today nobody show me any design well. Okay, so only 1 to 2 persons. Okay, anyway I hope in the future you will show me your task, because it is very important for me and for you to go ahead, otherwise it is very hard to work on different designs. Okay, because this is a training course, and I surely if you do not work, and you how you will learn these things. Okay, because there are so many courses on antenna that are only teaching these courses. Okay, but they do not allow you to work on design, but I am asking you to show me your design so that I can give you more suggestions. Okay, so it is important for both of us, all of us, I mean. So I hope in the next task you will show me your task in the lecture, not in the other time, like I will send you at night like this. Okay. Okay, so let's end the meeting, and see you tomorrow in the next lecture. We will discuss about the wideband antenna. Okay, wideband antenna. Okay, also we will discuss about ultra wideband antennas. Okay. Okay, see you